Now let's understand this law with the help of a schedule and a graph. But before going to the graph, let's first understand the schedule. Now this is the same schedule which we have used for understanding the TP, AP and MP. So we have taken the same schedule here. Now in this schedule, the first column is about labor. The second column is total product. The third column is average product. The fourth column is marginal product. We already know that total product is summation of marginal product. Average product is total product divided by quantity of variable factor. In our case, it is labor. And marginal product is total product at level n minus total product at the level n minus 1. Now here, let's just run through this schedule quickly. What is happening is, labor is considered to be a variable factor here. So what we'll do is, we'll start with one laborer, and we'll go on increasing the amount of labor in our factory. However, please note that other factors like land, like capital, machines, etc. are same. They do not change. They do not increase or decrease. What changes is only labor. So when we are increasing the labor from 1 to 2, 2 to 3, 3 to 4, 4 to 5, so on and so forth, the number of machines, the amount of land, factory, building, etc., every other thing remains the same. So now when we have one laborer in our factory, we see that he produces 100 units. However, when we increase the amount of labor, it becomes 2. The total product then is 210. The meaning of this is, when there are 2 laborers in our factory, they together produce 210 units. They individually produce units separately. However, when we take the total production, both of their individual products collectively, it is 210. Likewise, the production of 3 laborers is 330, and when we furthermore increase the amount of labor, the collective or the total product is 440 at that level, and this goes on increasing till we employ the 10th labor. Once we employ the 11th labor or the 11th laborer, we see that there is a fall or decrease in total product. So all this while, our total product was increasing from 210 to 330, 330 to 440, 440 to 520, 600, 670, 720, 750, 760. After 760, it's 740, so it's falling. We've also understood how to calculate average product. Average product is nothing but total product divided by the amount of labor. So at first level, when there is only one labor, he produces 100 units. So on an average, he will produce 100 units only. When there are 2 laborers, they produce 210 units. So the average product of both of them would be 105. That is 210 divided by 2. So this is how we calculate the average product. So in this column, we see that average product is increasing when we increase the number of laborers from 1 to 2. When there are 3, it is still increasing. When there are 4, it is almost constant. It is steady there, where it was when there were 3 laborers. But after this level, what happens is, now my average product is going down. As I am increasing my labor, my average product is going down throughout. Now let's see what is the case with marginal product. The marginal product of the first laborer is 100. When there are two laborers, the total product is 20. The total product is 210. We know that the first laborer produced only 100 units. So it is obvious that the second laborer produced 110 units. So my marginal product has increased. When there are three laborers, they in total produce 330 units. But I know that two laborers produced 210. So I can calculate that the third laborer must have produced 120 units. So again my marginal product has gone up. However, my marginal product goes up only till the third level, wherein there are only three laborers. After the third laborer, when I increase the amount of labor, my marginal product goes down. It still is going down. And finally, it goes negative. This is the stage where marginal product is negative. It has gone below zero. Now, because marginal product has gone negative, you can see that there is a fall in total product from 760 to 740. There is a decline of 20 units in marginal product. Thus, we can see total product is the summation of marginal product. Now, let's understand the schedule with the help of the graph. In the graph, we take output on y-axis and input on x-axis. Our input is nothing but the variable factor, which is labor in our case. Just for your understanding, in economics, as a convention, we generally take the variable factor on x-axis. Whatever the variable factor may be, it may be output, it may be a factor of production, it may be the amount of money, it may be the price level. Whatever is variable is generally taken on x-axis, and the other factor or the other element is taken on y-axis. Let's come back to the law of variable production. Now we have the coordinates. This is labor, so this becomes my x coordinate, this becomes my y coordinate. With the help of these two coordinates, what I do is I plot points on the graph, and then when I join them, I get this curve. And this curve is nothing but the total product curve. It's the total product curve. Now in the total product curve, as it is denoted in the schedule, we can see that the total product initially increases, and after a point it starts to settle down a bit. It becomes steadily increasing. It does not increase at an increasing rate, and finally when it reaches its highest point, it starts to fall. This is what is shown in the schedule. If I were to tell you this is the stage till when the total product is increasing at an increasing rate, we can see that the total product is increasing. It is not only increasing, but it is going up at an increasing rate till this stage. After this stage, the total product is still increasing. It's still going up, but it is becoming flatter. It is not steep as it was earlier. It is now becoming flatter. So we can say that it is increasing at a decreasing rate, at a diminishing rate. And finally, after this point H, it starts to fall. And thereafter, it continues to fall. So, the stages that I have told you and we have marked with the dotted lines are the first stage, increasing returns. Then we have diminishing returns, that is the stage 2. And finally, we have negative returns in stage 3. Now, why do we call them increasing returns, diminishing returns and negative returns? Let's see. We've only understood the curve total product here. Now let's understand what is the case with marginal and average product curves here. The average product curve can also be drawn on this graph because we have the quantities of average product in relation to the amount of labor. So taking the values of labor and the average product, we can mark the average product curve here. So this is the curve that we would get. And likewise, if we join all the points of marginal product, this is the curve that we'll get. Please note that I have taken the total product curve in red, the average product curve is in green ink, and the marginal product curve is in blue ink. So initially what happens to the average product curve is it goes on increasing, and when it reaches its highest point, it then starts to fall. It then diminishes or decreases. Same is the case with marginal curve, marginal product curve. The marginal product curve initially increases, and when it reaches its highest point, it starts to fall from there. But marginal curve starts to fall before the average product curve. Now we've already done the relation between marginal product and the average product in our earlier slides. So the point to note here is the marginal product curve intersects the average product curve when the average product curve is highest, is at its peak. This is when the marginal product curve intersects it. And then marginal product curve goes below the average product curve. Marginal product curve initially starts above the average product curve. It cuts the average product curve where the average product curve is maximum, and finally after that point it goes below the average product curve. Now in my last video I've told you to consider the marginal product curve as a magnet. The same thing can be verified here. You consider the marginal product curve as a magnet. Now marginal product curve is above the average product curve initially. So what it does is it pulls the average product curve towards itself. It pulls it up, and this is why the average product curve is increasing. However, when the average product curve is cut by marginal product curve and marginal product curve goes below the average curve, again the magnetic effect of marginal curve, rather the marginal product curve, comes into action. It then starts to pull the average product curve towards itself, and this is why the average product curve falls or comes down. So this is how we explain the relation between the two. Now what is relevant here is the point S. You can see at the point S, the marginal product curve is intersecting or cutting the average product curve, and this is where our first stage ends. Our first stage started with zero production. We went on increasing the amount of labor. Our production started to increase, and at point S, our first stage ends. So this is where our first stage ends at a production level of ON. When we have produced the quantity ON of our product, we have come to an end of the first stage. This is the stage where we got increasing returns. Our marginal product curve was going up, so was the average product curve, and because of these two, the total product curve was also increasing. But since now the marginal product curve has cut the average product curve, the average product curve will now start to fall. And since it will start to fall, our production will increase, but it will increase at a diminishing rate. So this also marks the start of the stage 2. In this stage, we experience the diminishing returns. Now, diminishing returns does not here mean that we get falling returns or negative returns, that the total product goes down, that the total product starts to fall. No, the total product increases, however, it does not increase at the rate it was increasing in the first stage. It will now increase at a slower pace, at a slower rate. And why is that? Because the average product has now started to fall. It has started to decline. So in this stage, we see that the total product curve becomes a bit flatter. This is in the second stage. The total product curve is now bending towards the x-axis. It is not rising. And finally at point H, where it is maximum, where it is steady, the second stage ends. This marks the end of second stage. But if you take a close look at this very level, if we are at the point H and if we come down running through H to M, we see that the marginal product curve at this level is 0. It is cutting the x-axis here at point M. So we can say that when the marginal product is 0, total product is at its highest. It is maximum. Maximum. But after this point, since the marginal product curve becomes negative, it is beyond or below the x-axis, what happens is the total product curve starts to fall. It starts to decrease. It starts to decline. Now what happens is the total amount of production that we had, it also decreases. It depletes. It vanishes away. Now this is a very difficult thing to understand. How can the total product, which was 760 when there were 10 laborers, become 740 if the number of laborers increase? Now this is a very difficult thing to understand. We come to this when we are in the third stage. So till the second stage, we have learned two things. The first stage ends where the average product curve is maximum, and at this point marginal product curve is equal to average product curve. You can see at point S, marginal product curve is cutting the average product curve, and when it is cutting, it is obvious that both of them will be equal. So the first stage ends when the average product curve, which is in green here, is maximum. And when the second stage ends, the marginal product curve is 0. And the corresponding point on total curve or the total product curve, if we see, we can see that the total product curve is maximum. It is at its highest level. It is at its peak. So the second stage ends when the total curve or the total product curve is maximum and the marginal product curve meets the x-axis. And finally, the third stage starts when the marginal product curve goes negative. It goes below the x-axis, and thus the total product curve starts to fall. So there are three stages in the law of variable proportions. The first stage, where we get increasing returns. The total product increases at an increasing rate because the marginal product is rising, so is the average product. The first stage ends when the average product is highest, and this is the point where marginal product intersects the average product. This also marks the beginning of second stage. In the second stage, we get diminishing returns. The total product increases but at a slower rate, at a diminishing rate. The second stage ends when the total product is highest, and at this level of production we see that the marginal product is 0. And finally, after this, we enter the third stage where the marginal product is negative and the total product starts to fall. In all this, there is one point F on total curve in the first stage. This point F is known as the point of inflection. Now why do we call this point as a point of inflection? It is because there is a flex or there is a bend in the curve at this point. At this point, the total product curve starts to increase at an increasing rate. So this leads to a bend or flex. And when this happens, we call this point as a point of inflection. Now we know that we have three stages in the law of variable proportions. The first stage is the increasing return stage. The second stage is the diminishing return stage. The third is the negative return stage. Now, the important thing to understand here is the logic as to why this happens. What is the rationale behind this increasing or decreasing returns in total product? Why in the first stage the total product increases at an increasing rate? Why in the second stage the total production increases at a diminishing rate? And why in the third stage the total product falls?